Welcome to that of the JAM question solution 2024, and these questions has been taken from my students especially on the memory based. And the first questions regarding the NMR spectroscopy. In the NMR spectroscopy, it has been shows that the styrene derivatives, and these styrene derivatives has two type of the methyl groups, and we know that the NMR spectroscopy diastereoic protons gives the different signal and the enantiotic protons give the same signal. Here the two methyl groups are diastereopic, so they gives the different signal, and here the two HD protons are enantiotropic, gives the same chemical shift value, and two He protons also enantiotropic gives the same chemical shift value, and He protons gives the different chemical shift value. So the total 6 signals present in the NMR spectroscopy. From the NMR spectroscopy, it has been shows that the enantiotropic proton and homotropic proton gives the same signal, and the diastereoic protons give the different signal. Here the two methyl are diastereopic as the plane of symmetry is not separated by the two methyl group, and the HD protons are enantiotropic as the plane of symmetry is present, so the HD protons are enantiotropic, He protons also enantiotropic. Next problem is the diplomen related problems. In the diplomen related problems, different type of the alkyl halides are taken. So we know that the methyl chloride has higher diplomen than methyl chloride. This can be explained by the mu summon E into L. Here though the electronic charge on the chlorine atoms is lower, but the CCl distance is greater, so the product mu summon E into L for methyl chloride is greater than methyl chloride. Here in case of methanol and dimethyl ether, the dipole moment is reduced by the OH bond moment, and here the methyl bond moment is comparatively greater, reduces the dipole moment compared to that of the OH. So the dimethyl ether has lower dipole moment than methanol. Next is that of the TCP versus KCP enolate, and TCP versus KCP enolate, we know that the if the base size is lower, then it take up that of the more substituted hydrogen atoms and gives the TCP enolate, and we get that of the TCP enol substituted alkyl derivative. And we know that the LDA is the highly sterically hindered base, is take up the less hindered proton, and gives that of the KCP enolate and gives the 2,6-di substituted cyclohexanone derivative, and this problem has been taken from that of the Clayton books. Next problem is that of the oxidation and reduction. In the oxidation reduction, here the metachloroperbenzoic acid has been used, and we know that this is the Beer-Blaser oxidation, and in the Beer-Blaser oxidation, the more substituted alkyl group is migrated and the oxygen inserted on the bridging carbon atom, and to give that of the ester derivatives. This ester derivative undergoes lithium aluminum hydride reductions to gives the alcohol derivative, and this lithium aluminum hydride we get that of the after rearrange the structure, we get this type of molecules, and this also taken from that of the Carothas book. Here the strychnine derivatives, and strychnine derivative, how many chiral center present in this molecule, and this here the 7 carbon atom, 7 center are present in the as the chiral center. Here the nitrogen atom is the chiral center as the one lone pair is present on the nitrogen atom, and this 16, 7, 8, 13, 14, 12 all are the chiral center. So total 7 centers are present in the strychnine alkaloid derivatives. Next problem is the elimination reaction problem. Here the two isomer is given, one is the cis isomer, another is the trans isomer. We know that the anti-periplanar geometry is more favorable for the elimination reaction. So in this isomer the anti-periplanar geometry is maintained, so the cyclohexene derivative is more preferred compared to that of the cis isomer. Next problem is the aromatic substitution related problem. Here the electrophilic substitution rate, we know that the electrophilic substitution depends on the following mechanism. Here the electrophile is attacked to produces the carbocation derivative, and after elimination of the H plus ions, it produces the aromatic substituted derivatives, and we know that the higher electron dense aromatic ring gives the higher electrophilic reaction rate, so the anisole gives that of the higher reaction rate for the electrophilic substitution reaction, but the fluorine contains the higher electron withdrawing capacity, but it has also electron donating effect, but the fluorobenzene has lower reactivity compared to that of the benzene, and this is the reaction rate compared to that of the benzene, where the fluorobenzene has higher reactivity compared to that of the bromobenzene, as the bromobenzene has the 3p2p mismatching overlap, so the electrophilic rate of substitution is lower. But in case of the fluorine, the 2p2p matching overlapping take place, so the fluorobenzene has higher reaction rate. So the rate of reaction order for nitration reaction is the anisole, benzene, fluorobenzene and bromobenzene. This is the pericyclic reaction where provitamin D2 undergo 1,7 hydrogen shift to gives the vitamin D2, and ergosterol is also can be synthesized by the electrocyclic convertation or ring opening reaction in presence of the sunlight. And this is the NGP type reactions where the 2-bromo-propanoic acid converted to that of the substitution reaction either in the NGP pathway or in the SN2 pathway. If the NGP pathway is preferred, then the configuration is same. If we taken the S2-bromopropanoic acid, we converted to the S-lactic acid, but if the concentration is higher, then that SN2 reaction occurs, so we get that of the R-lactic acid from S2-bromopropanoic acid. And this is the stereoisomer, and this stereoisomer, how many stereoisomer present in the molecule? In the this is the book shape structure. 2 cyclopentane ring is fused. Here the 2 OH group present in the same side, and one OH group in the above side, another OH group in the below side, and here the 2 OH group may be in the below side. And this is the optically active, as the plane of symmetry is present in the molecule, and this is the optically active. So the DL path of total 4 isomers are present. 2 are optically inactive and 2 are optically active. Thank you for watching this video.